Hey there, welcome back to the channel. I'm back with new looks, new haircut, new curtains, but the same errors. Uh, yeah, that's a really great saying, The errors persist, but so do we. So do we. So let's just get started. First, I would like to start with a note, which is this one. Never be afraid to make a mistake, unless it's Git, then be afraid. Be very afraid. I made a mistake in Git and boy did I regret it. And it was not a massive one, but yeah, uh, let's just get started. In Vim allocator dot C, I use NVim by the way. Sorry, I should say new Vim. I use new Vim by the way. I don't use a what is that? I don't use a LSP by the way. That's not a flex. That is really. I am just not that smart enough to like set up a LSP. I'm like it's. I don't think it's about smart, but I'm a very lazy person. I don't want anyone auto-completing my stuff. Even the brackets, I don't like or like take a look at this. So if I write a if statement, so if A, B, C, D, see, even the brackets don't complete. I just don't like it. I just don't like stuff auto-completing my stuff. Oh, sorry, my bad. Boop, 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 boop. So we were going through an error. What was the error? Well, I will just, first I should check out, wait. Okay, okay. Yeah, I forgot. It's realloc. Yeah. Yep. And this is the old code. That's correct. And if we do this, make and oh, I forgot. Let's just try to compile first. It does compile, but it won't work. Boom. Segmentation fault. So we have to take a look at why we are getting a segmentation fault. That's what this video is about. This video is just about me fighting with segmentation errors. I guess, you know, like GCC has a better error message. Like, they get a segmentation error and then it says code dumped. Like, that sounds cool. I'm not sure what core is, but it sounds cool. Wait, am I at 1 decibels? Yeah, I should increase that. Yeah. So they get a core dumped error, and it is here is just segmentation fault. Just segmentation fault. Sure. Let's just get started. So let's compile with the debug mode on and the DB and driver. Well, I actually know for which you can say what for which test case we are getting the segmentation error. It's the realloc one. So let's just try that. So this was inside traces 9. Oh, I forgot. Yup, allow. So yeah, so lib system platform DYLB. This is for so this is the memory move. And why are we getting this error? Because our malloc function is returning null, which it shouldn't. But let me show you. So if we move this by, what was that? Up? Yeah. So if we take frame variables, so the new S is supposed to be the new block, you can say. So it's supposed to be new block, and we have to move pointer like block size bytes which start from pointer to new S, which is the new space. And our new space is, as you can see, it's null. and it is being returned by malloc function. So why is well, it shouldn't be my malloc technically. It should be our malloc. Our project's name is our malloc, you know. So why are we getting that? So that's what I have to figure out. Boom. So somehow malloc is returning null. Why is that? So we get null only when. Let's say I try to do this. So printf, I try to print space about this, the boom boom. So at least I will find out like which portion is returning null. I don't think mem is this block of code will be returning null because this is just calling mem is VRK. I don't think it does. Like anything that might cause some kind of errors, but let's just take a look. So this is what we say. What was that? I forgot. Yeah, it's space. My bad, bro. And then we have allocated s over here. So space uh, e space. How about that? Boom, 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 boom. And we have allocated s. So oh, I should make another tab. Make We are about to see a lot of things. Driver dash f traces 9. Okay, so here we are. So A space, we got that in A space, which is allocated space. Hmm, hmm, 48578. Let me just take a look at this. So hex to decimal, 48 is 1240 and 578 is 1400. So the difference is 160. That's correct. I guess there are some alloc functions that require 160 that are asking for 160 bytes inside the trace file, which is this file. So this is fine, and it gave an error, ran out of memory. So our allocated space, so this one gave an error. And why did it do that? So how about we set what do we call it? Oh, I forgot. Um, a breakpoint. Yeah, let's set up a breakpoint over here. I should have done that earlier. Why didn't I do that? Because I am a lazy bunch. Uh, did I modify anything apart from the function? No, that's fine. That's fine, bro. Now let's set up wash points. Exit. Yes. Boom. And now we can clear this. So make again with debug equal to 1. And then we call LLDB with M driver. We set up breakpoint. What was that? Is breakpoint set expression? Breakpoint set expression. Oh, I forgot that command. Oh, okay. Breakpoint set expression. Well, it was not expression, it was something else. Damn, I forget that. Breakpoint set LLDB at a line. How do we do that? breakpoint set file line number, or I can just do, the LLDB one. Yeah, see, this is what I want. Yep. Breakpoint uh, allocator dot C at the line number. What is the line number? Line number 260. Yep, let's do it. 260. And now we run it. Run traces. And now, yep, we are over here. Variable. Can we set a condition? This is going to take a lot of time, right? I want to go inside that function. Set breakpoint if a condition is met in LLDB. Conditional breakpoint. I would like to set a conditional breakpoint with LLDB that is usually done using dash C option. In my case, I want to test if a string object is equal to a certain string value, but doing this. Okay. Oh, so we are supposed to use dash C. Okay, yeah, sure. So let's just say I'm looking for, let's just go here. So I'm doing traces 9. Oh, yeah, okay. And this is 160. See, this is okay, I messed up, I guess. We allocate what is that? D plus no space D no D plus what? Well, I know D, and let's say I want 128. Oh, it's going good. How about I want 160? Well, you can't do that, right? Duh. 160. Let me do that. So allocate 467. How about I call for 128? How about I call for what do we see? Uh, regex for a number regex for any number. Let's see. In your way. Yeah, yeah, I knew that. I definitely knew that. 160. Oh, there isn't a 160. So was it supposed to be 160 minus 32? Yeah, it must be 128. Yep, because 32 bytes is going for header plus footer, so that is the split block. So something is happening because of split block. Breakpoint, delete one, continue. Hmm. This is going to oh 33604 it. Weird. Pretty weird. How about if we add a condition over here? So we will add a condition over here, which is if allocated s happens to be null, then printf allocated s is null. That's how we are supposed to do, right? And I will make debug and I will run LLDB once more. LLDB driver run. Oh, I have to set a breakpoint. Allocator.c at line number 262. Okay. Am I recording myself? Yeah. Okay. 16 minutes in. Yes, we haven't made any progress, but that's fine, you know. It's not about the progress. It's about sending a message or whatever. So we okay, so this is set. And now if I run dash f run and if I do this should work. And it's going to. Hmm. Did I miss something? Hmm, what did I miss? So if I have a void pointer p is equal to null, and if I do printf p is actually percentage p boom 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 p itself. Sorry, client temp.c. I'm so sorry. I'm supposed to do standard io.h. Yeah, it's zero. Okay, so it's not. So it's not this. What is this pointer? I think it's the end of the heap, right? Oh, it had loaded. Okay, pointer value. So what does that denote? That's what I want to know. How to check if pointer address has the value? That's what I wanted. Like, oh my God. Stack Overflow is literally what I think. Casting -1 to an unsigned char pointer will, on a typical compiler, produce a pointer value of either 0x. Okay, casting -1 to an unsigned char. Okay, let me see. I'm trying to dereference a pointer to an unsigned char pointer, but the program caches with a segfault because its value is always this. Before dereferencing the pointer, I would like to check whether it is pointing address is different than this to avoid segfaults. How could I check that without hardcoding the check against this? That is like this. I was searching and found this. The unsigned integer pointer max seemed to be maximum value of the integer the pointer is pointing to other than the maximum value of the pointer address. The problem is consistent in every single segmentation fault. The pointer has a value this. I know I should fix this application so the pointer is not set to an invalid address, but the code base is quite big and complex and I'm not sure how to reproduce the problem yet. So while do not figure out how this pointer is set to an invalid address, I would like to put a protection. Just out of idle curiosity, how can I purposefully make a pointer to an unsigned char pointer point to the address this, maximum address on the target machine? My program is doing this somewhere, but I have no idea how as I am still searching for the culprit. Casting -1. So, okay, so this is the pointer, is this. Hmm, okay, let's do that. Let's try that. So, what they were asking for is that, oh, sorry, hold it. So, I have to cast unsigned char pointer, that's -1. So, this should work, right? So, let's just simply compile this first. So, make and add n driver. We did not get that. Yep, it did not happen. Hmm. So this is the pointer value. Hmm. 48. Sorry. Wait, the pointer. This pointer. 758, 748. Oh, it's increased so much. Wait, so is it's not freeing up the past memory? That what is happening? Damn, damn. Do you understand what is happening? Just take a look at this. What are we doing over here that I'm messing up so much badly? What is happening? Think about it. So, this is the code. What is happening is that we are comparing that the current size. So let me just go from the start. Let's let's go from the start. Let me explain the context of the entire code. So this is the realloc function. What realloc function does is that we get an existing pointer. We say that this pointer points to a block. Well, the block is kind of, it's not enough for me. I want a new size. This is supposed to be a size. The block can either be shrinking or it can be, expanding. We are not sure about that. In case the block is shrinking, we don't have to do anything, right? We just have to check if the difference is at least header plus footer. So what that means, if it is at least header plus footer, that means we can split the block. If it's not, we'll just return the same pointer because we can't do anything. So this logic is covered. The left free block and right free block, so this part of the code, what it does is that it checks if the block that we are, so since the block is going to expand, well, and the block is not enough, since we checked over here, if the block is not enough, well then, else if block size is greater than or equal to line size, this should be greater than or equal to, right? Hmm, my bad. So yeah, okay. So the new space that we need is definitely going to increase. So we'll check if the blocks at the left side and the right side, whether both of them are free. If they are, or whichever is free, we just coalesce them. If none of them are, then it's fine. We just get current to set to the pointer minus header. What is this? Just, I'm not going to explain it. It's too deep. Like, it's not that deep, but I've explained that a lot of time in the previous videos. And nobody's going to watch this part of the video. If you're watching this, well, thanks for watching this, bro. Most of the people don't watch it this far. If you're watching this, I would like you to know that I don't want you to watch this video any more further because I'm just going to debug this stuff. I would like you to close this video. I would like you to, sorry, I would like you to close this video, close YouTube, and make your own project. Go ahead. Uh, I'm not sure because I think most of my videos are watched by, sorry, I'm really sorry. Most of my videos, the YouTube analytics, it shows that my videos demographic is like in the age range of 25 to 34. And if you're watching this video, I think you might be like you might be decently good at coding. Maybe if you're not, it's fine. And if you are, go ahead, make your own project. Why are you watching me? I'm just going to take up another 1 hour and make this video like 1 hour or 2 hour long. I'm just going to try and debug this stuff. If you're watching this video, close this, make your own project, learn something new. You're not going to learn anything on this video apart from me like trying to figure out some stuff, and you guys will be like, so there might be some guy like watching this video that would be like, oh, he might be knowing like, bro, don't do that. This is the error. We all can see this error. And I'm like over here, this might be because of the print statement. I added the print statement, and that's when the error started. So yeah, it's just going to give you a high blood pressure. So yeah, you know, if you still want to keep watching this video, well, thank you. You know, let's just get back. Damn. Let's just get back to the video. So we get the current header, we get the current size, size this one, current footer, current space, and current E means current end. So why is that? So the thing is that if so why did I get the current end over here? So let me explain. So so whenever you will see the suffix underscore s, that means it is the space value. What is the space value? Well, our block looks like this. Let me show you. So our block looks like this. So we have a header, plus we have the actual space, plus we have the footer. Header is of 24 bytes, space is of X, and footer is of 8 bytes. As you can see, the default most minimum space is equal to 32 bytes. That is the smallest block. It doesn't have a space, that's why it is 24 plus 8, that is the smallest block. Well, oh, I messed up again. So there was I. Yeah, I was over here. So this is the why are we checking the end? Well, we are checking if a block that needs to be reallocated is at the end of the free list. Because if it is at the end of the free list, we don't have to do a lot of things, right? What we need to do is we just have to increase the break pointer, which is like the heap pointer. So imagine heap is like this. It's how can I say? Imagine heap looks like a stack. So the thing is that in memory, it is usually visualized as like the stack growing downwards and heap is going upwards. So let's just imagine the same way. Sorry. So let's just say So this is the break pointer. So let's say this is the how about this? So let's consider this as a heap. So what happens is that whenever we want to allocate space, we just move the pointer above. So this difference was allocated. So let's just say our allocated block is already at the top of the heap, and we want, let's say, some additional space. Well, we don't have to call mymalloc for the entire space, right? Whatever we want. What we will do, we just allocate the extra size. We just call directly mem is PRK, and we allocate the space needed, which is align size minus current size, which is the difference. So this is O of one space. We just use the so this is O of one realloc. A small optimization. That's what I did. So what did I mess up over here? You might be wondering. Well, where did it go? Oh, I forgot. Where did it go? Mm, there was it. Oh, come on. Where was it? Where was it? Yeah, over here. So this is the thing. So here I check if our current E. So this is current E, which is the current end. If it happens to be at the end of the like, if it is at the end of the heap, the top of the heap. If it is at the end of the heap, then we just allocate the new space. Well, and if it is not at the end of the heap and it's increasing, and then what we can do is we will just call mymalloc. We will move this, but I never freed the previous pointer. That's what I'm supposed to do, Adi. Why did you forget these kind of simple things? Why do you do that? Why? Why do you do that? See, it's working and it's giving us a very bad score, but that's fine. It's working. Look at that throughput. I'm proud of that throughput. Okay, so this array has been fixed. Our space is being utilized. It's not being utilized definitely in a good way, but it's working. You know, it's working. So let's just try that. What does a get diff look like? So get diff, we added a condition if until, yeah, let's remove that. It might be because of our print statements too. Yeah, let's remove this. And yeah, this is fine, this is fine, this is fine. Yeah. So now what does our get diff look like? It's looking good. Okay. So make mdriver dash, no, just mdriver. Oh, verbose 65. Okay. This is because our utilization, wait, this is throughput, right? Okay, okie dokie, okie dokie. My Realec is performing worse than the most lamest Realec. That's what this is. It should have been more than 80. Need to fix that again. Boy, let's do it. Let's do it. Mm, Let's do it. So let me just take this. Why this might be happening. So should I read the realloc function again? Why are you doing this realloc? So let me show you too. So this is the lamest realloc. So what this does is that this just wait mem move mem copy wait why did I decide to go with mem move versus mem copy. Sorry, wait. So I'm trying to understand the difference between memcopy and memmove. I've read the documentation that memcopy doesn't take care of the overlapping source and destination, whereas memmove does. However, when I execute these two functions and overlapping blocks, does work. Wait. So they mean that memmove has an internal check that does not allow it to overwrite memory. Is that what you mean? So I'm trying to understand the difference between. Wait. There must be a man page for them, right? Oh, sorry. Yeah, okay. So memcopy function copies n bytes from memory SRC to memory area DST. If destination and source overlap, behavior is undefined. Sure, applications in which DST and source might overlap should use memmove 3 instead. Okay, so if they might overlap, then we should use memmove. That's what we did because sometimes our memory is going to overlap. Indeed. So using memmove was a good decision. I'll still check it out. I did not consider that, sorry. The memmove function copies a length of bytes from string to source to destination to string destination. The two strings may overlap. The copy is always done in a non-destructive manner. Okay. What does non-destructive manner mean? How does memmove copy move data? It doesn't have copy in it. No. It's used to copy block of memory from location to another. It is declared in string.h. Does this boom boom boom. So wait. Memmove current pointer block size. Okay. Hmm. What did I change? Oh, okay. Uh, one, two, three, four, five, six, seven, eight, nine, 10, 11, 12. Hmm. Why is that? So let me show it to you guys what I was saying. So if I uncomment this and comment the new realm, the score is far better, far better. Look at this. If I use the lamest the lamest realloc ever, then it's a better score. What? How is that fair? How is that fair, bro? Fair, bro. Okay, so this is utilization 25. Make it again. Don't combine it. So what are you doing? Poof, 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 poof. What does it mean in a non-destructive manner? Actually, move a chunk. Biggie. Does move actually move a chunk of memory? If so, does it leave the memory with zeros? Or is it like memcopy? I'm looking at the man page and I do not believe my assumption is correct. If I want to move a chunk of memory using memmove, would I have to manually zero out the chunk of memory did move, where I did the move? So memmove has nothing to do with clearing the old memory, and in fact, in the only situations where you want to use memmove, clearing the old memory would destroy the data you just copied. That's because mem only is only useful when you expect the source and destination ranges to overlap. Sure, usually if you find yourself needing mem move, it's indicative that you have a major fundamental inefficiency in your design. For instance, often new C programmers will try to use mem move to remove the first few characters of a string that is, okay, rather than just using s plus 1 or and s1 to address the tail of the string. Algorithms containing memmove rarely perform better than O of n square. What if I switch this to memcopy? How about that? You know, I'm tired of memmove. O of n square. So does it perform checks continuously? Like, is it? I'm confused. Is it like doing some checks? You know that. Oops, sorry, I don't want to do that. Yeah, okay, it's three times. So mem copy. Sorry, let's try this. Nothing. No use. Picky, can't you see? I want to sing that song, but the thing is that I will get a copyright strike. What is causing this? Let's review our code. How about that? Oh, it's 6:56, 43 minutes in. How about we try to find this error? Yeah, we'll take care of that later on. So what if I try to print like so it's calling realloc again and again, right? And it's mostly increasing. So we should get a okay. So the first return statement inside realloc is over here and over here and then directly over here. Strange. This is current space. Okay. Okie dokie. So this is when current size is actually. So this is current size that we want and the line size that we want. If it happens to be greater than or equal to header plus footer, then do this. Split block, new split block. Picky, can't you see? Sometimes, sorry, I shouldn't speak that song at all. And if I do printf new percentage s, and I shouldn't do this. I should do mem heap, right? And it should be at the base of, well, it's fine. Let's add that. So printf new boom 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 new space boom boom boom, and in it I should add, sorry, printf new case stuff. Let's try that. Okay, where I did not get a case. That's strange. That's strange. Hmm. Well, we are only using the alloc for the zeroth index, right? Yeah, I guess. Then why are we seeing that over here? It's 18 running continuously. Look at this. This is weird behavior, right? So 18 is the initial block, initial one. When we go inside realloc, when we go inside realloc, we are only going inside it when the space is increasing. Hmm. 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 It's already 7 o'clock. I should upload this video, right? I have to do some other stuff too. I have to read a book. Um, I guess let's end the video. It's not great to, keep trying to do something that we can't figure out. Oh, I see that, then I feel like I am not putting enough efforts, and now I'm going to do that again. Let's just go. Okay, what is causing the block to do this weird behavior? Uh, how about we do this? How about we do this? So I get a size, I do city, I do comma, and then I say size and this. How about that? Okay, so these are the new sizes that we are doing this for. Strange. So we ask here for this space. It's so what is B8? B8 minus 18, that's what I want to find out. X to decimal. B8 is supposed to be, what is it, 8 plus B, which is 16. Let's not put that in the reference, 184. So B8 means 184 and 18 means 24. Sure. And if we try to find the difference between them, it is 160 minus 128. So this is 128. So we're getting this space and it's 18, 18, 18, boom, boom, boom. Why is it not enough? So when we get 400, so this is 128.7 increase. This is 128 again, I guess. This is also 128. 8 plus 6, that's correct. 128, 128, 128, 512. Let's look at the allocator file for now. You know, maybe we will find something strange over there. So we have allocator, allocated, allocator R, and then we have a pattern, I guess, which is right here. So AFR, 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 AFR. So this is the pattern. I've cracked the pattern. AFR. So this is where the pattern starts from. So let's take a look like what is happening. So let me get my whiteboard. Let me also zoom this in. Well, you aren't going to see the stuff. So, oh, I'm also supposed to do an important work. I did not do that. Okay, what time is it though? Hmm. Okay, okay, okay. Okay, yeah, okay. So if you take a look at this, uh, so let me, yeah. So this is our heap, our initial area that has been allocated. So we first ask for 512 bytes. So this is what we get. This is allocated block. Then we ask for 128 again. This is what we get. Sorry. Then we reallocate 0, which is this one. Oh, I should number them. Sorry. We reallocate 0 to 640. So since we can't reallocate, I'm so sorry. So this becomes free. Yeah, since we can't increase the block. So we have to completely reallocate it. So 640 over here. So this is 0. And then we allocate 2 to 128. The second process 128. So over here, so this is 2. The remaining space is 512 minus 128 minus 32. So if you sorry, so 128 will go, so 32 will go because for the another this blocks had an footer. So 82, the addition is 0, boom, 6, 160, 160 gone, 0, 12. Oh, why did I do that? I'm so dumb. 2, this is 4, this is 10, right? Oh, this is supposed to be 11. No, this is 10. Oh, I'm such a dumb person. 4. I don't even know subtraction now. So this is 342. So it's 342. So this is 342 bytes. I'm really embarrassed right now because I'm going to use a calculator. Uh, 512 minus 160. It's 352. I am dumb. I'm really dumb because it's supposed to be 11. I was correct. And marker is important. So this is 352. Oh my god, please work just for a little bit. So this is 352. This is still free, you know. And then we reach. So this is where our AFR pattern starts. So this was allocate 128. Then we free one, which is 128. So this is free now. Yeah, if we merge this, we get 512 again. They are back again. Boom. We are free. 512. If and then we reallocate 0 to 768. So this has been increased. We just move this over here and then we do 768 or whatever. We allocate 3 to 128. 3 to 128. So this is what happens. 128, 3, 3, 52. Allocate 3, 128. And we free 2. So this is free. We reallocate this to 896. Allocate 4, 128, which is this. Free 3. So this is free. So we merge this. 512. Reallocate 0 to 1024 and allocate 5 128. So the same thing goes on. The space should only be increasing because of allocate 0. Ah, so the space should be increasing, the mem heap high function. It should increase. But why is this giving us this is pretty much repetitive. So we are seeing that, okay, about this. So stuff, our allocation for 640 starts over here. Then we go for 768, that's fine. And then it comes back again to one. That's weird. So it correctly starts from 2D8 and 2D8 is supposed to be 512, maybe 512, 512 plus 32, so 2D8, right? So 2D8, if I'm not mistaken, it should be 512 plus 32, which is 544, 728. And why is that? So the initial block is 512. Oh, then we have another alloc of 128. So it becomes 628, and then we reallocate to 640. So over here, side 640. What's this inside reallocate then? Why did we reallocate 640? There was no call for the 640, right? Reallocate 0 to 640. Yeah, it's there. So 512 plus 128, so 620, 640 is what we have, and this is showing 728. Oh, the both of the blocks must have their own stuff, right? So even if it is, so let's say the first block is 512 bytes. So 512 plus 32, my marker isn't working. So if the first block is 512 bytes, it's not just 512, it has its own header and footer, so it becomes 544. And then we have a 128 block, and it has its own header and footer, so it becomes 704 at max. Then why? Why are you showing 728? Why is my 728? Where did you get that value from? 24. You getting me, right? So 2d8 isn't supposed to be. Oh, this is the new pointer. That's fine. New it's supposed to be 728. That's correct. New is supposed to be 728. That's fine. So I have to look into this case where the memory is over here, and then we increase the space, and new space is current space. This is the stuff that is causing the most errors for us. This is the stuff that's doing it. So current A is that we know that it is plus one. So if I add a condition over here, so let's say printf just increasing then brk pointer, you know, if I just add this and I do this, this should show us multiple things. No, it did not. It should actually. Then why did you not do it? What did it cost? What did it cost? Then which condition are you going inside, bro? Is it inside if? So print inside if. You never know, you know. So are you even inside if? Yeah, you are inside if, but not every time, apparently. After every five, what is that? After every six realex, you're getting a new stuff. And why is that? Let's check. Oh shit. I think that is what the error is. I think I will like to end right now because it's an hour. Oh, my camera. Look at that. I forgot to show you guys what I'm doing. That is crazy. Okay, I'm so sorry. But okay, I'm going to end this video. Thanks for watching this video. I'm Aditya Charney and I am an engineer for fun. Bye.